Okay. All right. So we're going to get started here. We're going to take a few notes, and then I'll call it a day. You guys are probably anxiously waiting the fourth question of the day. That is the Google question, the Google Classroom question you have to answer every single day, including if you're even in class. I don't want you to answer that question. So everyone will answer it every single day. You have to report to the Zoom every day unless you're in school. So keep that in mind. I sent out the links at night. So you're getting probably 3 emails a day from me. You're getting the email at night at about 6, 7 o'clock at night. I give you like the notes for the day, the video of the day, and the link for tomorrow. So I'll do that again tonight for the links for Monday. You get an email in the morning from me reminding you, hey, we have a Zoom today. Here's the times. Here's the link again. And then you also probably receive a 3rd email from me about the Google Classroom question of the day. And that comes right when class starts. It's programmed. I think it already went live about 5-10 minutes ago. So the question of the day today, so for those at home, it is what is the solution for the 4th example, the 4th problem we're going to do today? And the little instruction says you have to use elimination method. We're going to do the last 2 problems today will be elimination. That is the new process we started yesterday. I just very briefly introduced it. So if you were on the Zoom yesterday, that was the new type of problem. We're not going to go too far in depth today. My goal today is to really just solidify it and really introduce it again. Monday, we're going to hit it hard, and we're going to be using that method strictly and only that one. But I want to review graphing because you guys haven't seen me for a while. It's been since what? Last Friday since you guys seen me in person? So
Thursday for me.
Yeah, Thursday. Yeah, so it's been a while. So I can understand that maybe you're not quite understanding the graphing part of it. Maybe this is like super easy for you, and I'm really happy about that because it's hard to learn from home. I understand that, especially when you're just zooming in. I think the setup I have works. I think for us, you can see my notes. Hopefully, you can. You can see my face. We can interact still. I think I kind of have my tech in order so that you guys can experience a normal class period. But it's still hard. You still have to learn on your own. You don't have me to come into during the day and stuff. So, but you can always Zoom me anytime during the day. You can always email me and whatnot. Homework is still due tonight. So I know I submitted a worksheet 3-4 days ago to you, a worksheet 2.5 or something like that. It's a graphing worksheet where you have to graph and figure out those points of intersection. It's 3 problems on the worksheet. That is due tonight online. You have to submit it on Google Classroom. Take a picture of it, submit it to me. You can either take a picture, submit the picture to me on the Google Classroom, or you can attach that photo to a Google Doc and attach that. But everything from this day forward is attached on Google Classroom, except for the stuff from last week. So if you still are holding on to like last Friday's homework for some reason, because I know like Smith was gone, so she has an excuse. But if you're still holding on to that stuff, you need to turn that in physically. But everything from now on will be online. The reason why I'm expecting will be online starting Monday, full time, and not in person anymore.
What's that? Like if we go all online, what percent do we have to be at to come back?
We have to be below 20% for 2 consecutive weeks. And our absenteeism, and what I mean by absenteeism, because you're like, we're at home. If you're not reporting to Zoom, you're still absent. So if people don't Zoom in, or you're at appointments, or you're not doing your classwork and teachers count you absent, that's part of absenteeism.
So we'll be full distance for a while.
Yeah, it could be. Now, there is no data backing that up. I have no emails. I have no background information on that. That's just my personal feelings because we're really high percents for the county. So we're top 10 in the nation, I think, in COVID cases. Top 10.
Impressive.
Yeah, that was according to the press conference yesterday when they shared information. Take that with a grain of salt. I think it was like Jamie Halick was in here yesterday, and she was looking at numbers nationwide. And she goes, "We aren't even close." So I don't know where the numbers came from. So they shared it. So, all right, okay, all right. But enough of that. Let's get going. First example out of 4. I only want to do 4 examples today. The 4th one is the one you submit to me on Google Classroom. So. Example number 1. So if you have your notes out, please put your Chromebooks away. You shouldn't need them. You can just push them off the side if you're going to answer that Google question later. Let's go through our first example here. We're going to graph these. These will be normal graphing problems. Okay, so normal graphing. So here's the first example. Let's go with 4x minus y equals 3, and let's go with 5x plus 2y equals 7. So this is our first example, and I want you to get to see this. Okay, we'll graph this. Can you guys see that okay?
Yeah.
Okay, all right, good. I know this is kind of weird just have me sit here, but I think that's the easiest for everyone at home and you guys here, and I don't have to walk around and don't have to do too much here. It works, I think. So, all right, first, we got to graph this, right? So we have to get it into the right form. Remember, the form we always want to get to is slope-intercept form. It's this form. This is the form we want to get to. This is the go-to when we graph. The y is by itself, the x and the other numbers on the other side. So on both of these equations, we have to rearrange these. We do have to like rearrange that top one, we have to rearrange the bottom one and go draw them. So that's what you're doing on that worksheet today. This is like that worksheet that's due tonight at 11:59 p.m. This is what you're doing on all three of those questions. You're graphing them. So let's do the first one. I'll do the top one in like this purplish color. I should turn off my Wi-Fi. Otherwise, I'm going to get messages all morning. All right, so I'm going to move this 4x over. So if I move the 4x over, it becomes a negative 4x plus 3. And notice that I left that negative 1 in front of the y. It's still a negative sign, right? The negative sign was attached to the y. You can see it right here. That was a negative 1y. So when I move the 4x over, that negative didn't go away. Some people like accidentally like drop it off. That negative stays there. And now what we're going to do is we're going to divide everything by negative 1. So if I divide everything by negative 1, here's what it turns into. Y equals, so negative 1 divided by negative 1 is 1y. That's what we want. We want the y by itself. Then negative 4 divided by negative 1 is just 4 over 1. Or you can just put 4. The negative signs cancel out. That's great. And then a 3 divided by negative 1 is negative 3. This is what I'm going to draw here in a second. Now, if you just want to write 4x, that's fine. Did that make sense?
Yes.
Okay, so let's draw this thing out. So this one's going to start at negative 3 on the y-axis. That's down here. That back number, the b number in the back, that's this number right here, that's where you start on the y-axis. So I'm starting at negative 3. Then my slope is telling me to rise 4, because it's a positive, so it's going up, and the bottom number is always to the right. So I'm rising 4, running 1. Rising 4, running 1. Rising 4, running 1. And I'm going from that initial dot. That's how I did it. So up 4 over 1, up 4 over 1. And you can do it as many times as you want, and then you draw the line. Questions? Okay. All right, second one. Let's do it in green. Okay, so second equation, same exact thing. I'm going to move the 5x over, because I need to get this y by itself. When I move the 5x over, it becomes negative. Then I'm going to divide everything by 2. So this is where, these numbers are not really clean divisible by 2, but I'm going to divide them all by 2. Not really nice and clean, but you get the idea, right? I try to give a couple of these because I know sometimes when you graph, it's not clean. This is going to demonstrate why this is not the preferred method. 7 divided by 2. What is that number on a calculator? Is that like 3.5? Okay, so 7 divided by 2, that's 3.5. That's the number I'm starting at on the y-axis. So that number in the back, you can actually divide. Make the decimal, I don't really care. So I'm starting at 3.5, that's up 3.5. So this is where my first dot is. On the y-axis, it's up 3.5. Now my slope, since it's negative, it's dropping, and then the bottom number is always to the right. So I'm dropping 5 and running 2 to the right. So drop 5 from this green dot. So 1, 2, 3, 4, 5, and run 2 to the right. And then from there again, drop 5, 1, 2, 3, 4, 5, run 2 to the right, and you get the idea. And I'll draw this out. Whoa, that line was terrible. Where does it look like they're crossing? Yeah, you're absolutely right. Let me move that there. I'll highlight that. So it looks like it is crossing 1, 1. You can see that right at the bottom there. I kind of zoomed in there, super zoomed. Yeah, 1, 1. That's the answer that we should be getting. So, but that's the goal, right? We want to figure out where they crossed. This is the whole goal of that worksheet. Where is that point of intersection? Now, these weren't clean numbers. These were kind of nasty little numbers, but you're going to make an educated guess where you think it is. So you got to just be in the ballpark. Okay, remember, the right and left number goes first, and then the up and down number goes second when I write the coordinate. So it's over 1, so that's the right number, and then the up 1 is the second number. Okay, Questions? Okay, that was first example. Let's go second. We're going to graph this one again. This will be a second graphing problem. Let me make up a new one here. So let's go with, okay, so this is second example. This is not the one you're submitting on Google. Let's go with 8x plus y equals 5. And let's go with 2x plus 2y equals 8. No, we gotta, that's not 8. It would be -4. -4. Yeah. I want to make sure they land on a nice clean number. I don't want to have a situation where we land on a weird number. Yeah, let's do this. This should work out to be a nice clean number. All right. Okay. Let's draw. We're gonna do it the same way. We have two lines. We're gonna try to figure out where they cross. Remember, the goal is to always get them to this form: y equals mx plus b. So the y has to be by itself, the x and the numbers on the other side. So on this top one, what do I need to do? Yeah, you're absolutely right. And that's really the only thing I have to do, because it would already be solved, right? I move the 8x over, so this turns out to be a -8x plus 5. And then I can just go draw that. It's already ready to go. I'm going to start at +5. It should be 5, right? 1, 2, 3, 4, 5. And then my slope tells me to drop 8 and run 1 to the right. The negative tells me dropping. So I'm dropping 8, running 1. Dropping 8, running 1. And this is what it looks like. Okay. And now, same thing as the other ones. We're gonna I'll put this next one. Maybe I'll put in a purple color. We're gonna solve the second one. So we have to move that 2x over. So 2y is -2x minus 4. So when I move the 2x, it became negative. And now I have to divide everything by a 2. And this one works out nice and clean, right? The numbers work out nice and pretty. So it's -1x minus 2 if I divide everything by 2. If you want to leave that -2 over 2, that's fine. The back number is obviously just -2. -4 divided by 2 is -2. So I'm going to start at -2 here. And then my slope is telling me to drop 1, run 1, since it's negative. So drop 1, run 1, and I can already see where they crossed. They just happen to cross right at that one dot. And what is that coordinate where they're crossing? What is that coordinate right there? Say it again. Yeah, 1, -3. So 1, -3. That looks like right where they're crossing. So they happen to land right on top of each other, and it makes sense for the numbers. All right, so that's the second example. That's what your homework is based on. So that's submitted tonight at least by midnight, 11:59 p.m. So make sure you're doing show the work, show how you're graphing, and then tell me the coordinate. That's all I really need to see. There's really not a lot of work you need to show. Maybe off to the side you're writing down what your coordinates are. But again, if you don't have graph paper, you can always pick some up before you walk out of here. I have it. It's in that folder back there. You can see it's right next to the pencil sharpener back there. I have a ton of graph paper. You can pick that up. And you can, take a picture of that, and that's what you can submit. I had a bunch of people do that yesterday in class. So, all right. Now, for those at home, for those in here, is there any questions with any of the stuff that we had to do on the homework? Anything that maybe you're confused about? Why did I start here? Why did I go this direction? Okay. Hopefully we've done enough of this. We've done, 4 days of this? You should hopefully feel comfortable with it, I'm hoping. Yeah, let's get to the new stuff today. So this is the third example. So third example here. All right. So third example. These are going to be the elimination problems. So we need to introduce that elimination method again. Okay, so elimination. I'm going to just do a quick idea behind this. Remember, what we called this yesterday, this is called linear combination. It is a very analytical way of solving. It's doing the same stuff you're doing on graphing, figuring out that point of intersection. But but you don't have to worry about graphing it. You don't have to draw it. You don't have to like interpret, okay, where on the graph is it hitting? This will give you the exact answer every time, including if it's a decimal. This is actually the preferred method. It's not more difficult. It's actually just a more efficient way of doing these types of problems. So I'm just going to make up a problem here just so you can see this. So let's say that my problem is 2x plus 3y is equal to, let's go with 7, and let's go with 2x plus y is equal to 3. Let's say this is my problem, right? Okay, yeah, let's just, okay, so let's say this is my problem. Now this is going to be slightly different than the one we did yesterday. I'm going to slightly modify it, so. All right, the goal is to figure out where these things cross. So you could go draw this, you could go figure it out. But I want to walk you through the steps. Now, I consider this one easy compared to the other ones, so I'll kind of walk you through it. But let's kind of go through the steps here. So for elimination method, number one, the equations have to be written in this order. So this is called standard form. So if you're not familiar with standard form, this is the form that I wrote down, I think on the board on last Friday, the different forms. It's ax plus by equals c. This is the form I want these written in. X, Y, equal sign, and the numbers. So if you need to rearrange things, get them to that form. Then you want to stack them on top of each other, like I'm doing here, where the X's line up, the Y's line up, the equal signs line up, and then the numbers in the back line up. So if you need to do any like weird dragging things around and rearranging, you need to do that first. For the problems we're doing today, I'm not going to do that to you. I'm going to have them in the right order. Monday, completely different situation. So they're already in the right order. Now, the next thing, you have to look at one of the variables. So you got to pick X or Y. You need to see if one of the variables has the same number out front. So X or Y, do they have the same digits out front on one of the variables? X's. Okay, so I'm going to circle that. Do we agree the X's match? Okay, that's number one. If they don't, you have to make them match. That's the next example I'm going to show you. You have to make them the same digit. Okay, so we'll see that here in a second. That'll be the last problem we're going to do today. And now, the next rule that we talked about yesterday, one of them has to be negative. Is one of them negative? No. We have to make it negative. So what I'm going to do is I'm going to go through one of the entire rows and make the entire row negative. Because you can't just change one number. You have to change the entire thing because you have to keep the equation balanced. So I'm going to change the entire row to be negatives. Sometimes you have to do that. So if I change one sign, you have to change them all. If one of the numbers is negative, it will turn positive. Okay? Does that make sense? You're changing the entire row. And now the numbers match. They're opposites. I can add straight down. So this is the new steps we were talking about yesterday. We're going to add these numbers straight down once they're in that right form. What's 2 plus negative 2? 0. They literally eliminated each other. That's why it's called the elimination method. What about 3 and a negative 1? 2. That's 2 y's. Agree with that? And what about 7 and a negative 3? 4. And then what we do is once you're here, notice one of the letters canceled out, it eliminated. You can solve, that's just an algebra 1 problem. 2y is equal to 4. What would the y have to be? Say it? 2. Y is a 2. It works every time. I didn't have to graph. That's the y coordinate. So on my coordinate, like the answer, right, when we write coordinates down, my y number is a 2 when we graphed it. So the height is 2. Now, to find the x, you have to take your number 2 and you have to go plug it into one of the equations. I don't care which equation you plug it into, you have to plug that 2 back into the y letter. I'm going to pick that second equation. This is that second equation you're looking at. I think this is the easier looking one out of the 2 equations I originally gave you. And I always go back to the original equations, not the ones that I changed. So, and I'm going to plug the 2 in for y. Like that. So I replace the y with the 2 because y is 2. And then I solve. Oop, I don't know why I had an extra y there. So I plug the 2 into the y. Sorry.
So you subtract it from the...
Okay, good. Yep. So then I'd subtract this 2 over. So if I subtract it over, and then, so now that I've plugged in that 2 into the y location, now the next step is to divide, right? And so I'll divide, and so my x ends up being, what, half? And that should be the answer that works in both. So the x is a half. Now, why I brought this problem up? Like, why did I make this one? Can you imagine trying to draw this thing and seeing where that thing crossed? It crossed in between hash marks. It crossed at half comma 2. Half over 2 up in the air. That wasn't a nice clean hash mark. This process is way more efficient. It gave me exact answers, including decimals. And I don't have to guess at it on the stupid graph. All right, questions on this one? If you're at home, you can ask questions, fire away, you can put in the chat. I'm looking at the chat here. If you want to just pipe up, just make sure you unmute yourself. Hopefully you're not been trying to ask questions here. I haven't been ignoring you, hopefully. Okay, last question of the day. This is the one everyone's waiting for. What is the last question? What's the one I need to enter in the Google form? Remember, I want the solution, so I want the coordinate. Okay, so here it is. We're going to do elimination. This is my last example of the day, and then we're done for the day, and you're done for the weekend. Make sure you take your stuff home tonight, in case we're not back Monday. Hint, hint. Let's go through a problem here. Let's go with, and I'm going to make this problem up so it's not going to be nice and pretty. Let's go with x plus 5y is equal to, let's go with 19, and 3x plus 3y is equal to 21 or something like that. Yeah, let's do that. That'll work. Okay, so this is my problem. Okay, now, just like I said before, this is my last question of the day. I've alluded at this fact that you need to first stack them. Do you agree they're in the right form? Standard form, right? The x's are lined up, the y's are lined up, the equal signs are lined up, the numbers are lined up. So it's in the right form. If you pick one of the letters, do they have the same number out front? No, they don't, right? They don't have the same number. We need to make them the same number. So you can pick any letter you want. There's one up there you should pick. So you want to pick one of the variables, x or y, and you want to make them the same number. What letter should we pick? X. Probably x's, I agree. That's the letter you should pick. It's easier making them the same number. So when we pick x's, that's the letter we're picking. This is a 1, right? We're picking x's. How do I make them the same digit?
We have to multiply them, don't you?
Yes. What number do we have to multiply on the top row? A 3. We're going to multiply the top row by 3. The entire row. Because it's just like the negative sign earlier. You do it to one number, you have to do it to the entire row. So if I multiply the top row by 3, I'm going to get 3x plus 15y. And then if I multiply by a 3, this turns out to be like 67 or something like that. No, 57. 57. Is that 19 times 3?
Yeah.
Yeah. Okay. Yeah. And then the second equation, I'm just going to leave that one alone. Why am I leaving that second one alone?
It's fine.
Yeah, it's fine. It already has a 3. I don't need to change it. You can multiply the two equations by different numbers to make them match. So the top row I can multiply by 3, the bottom row I can multiply by 2, and to make them the same digit. So if you would have picked y's, we would have had to do that. If I would have picked the y letter, we would have had to multiply both rows by different digits to make them the same number. I probably would have made the y's maybe 15s. I could have made them both 30s. You can make them any number you want. If I wanted to make these x's both 12s, I could have done that. Multiply the top row by 12, the bottom row by 4 to make them both 12s. You can make any number you want. I just say pick the easy number. You want to say hi to any of my students online?
What do you got?
I got about 5 or 6 of them. So
Who is it?
We got Andrew, we got Hook, we got Gouge, we got Mason Graham, we got Skyler, we got Griman, and we got Waymire.
Nice.
So.
You getting good feedback on doing it this way?
Yeah, I think so. The kids don't seem to mind. So they haven't,
okay for you
they
guys
haven't complained yet.
Yeah.
Yeah,
So.
except for the beginning, I had to tell them that there was just one tiny strip for the
Oh.
iPod that was coming through.
Yeah,
Oh, gotcha.
yeah.
Good.
So.
Good.
Yeah, all right.
All right, thanks, Mr. Ward.
Yeah, no
Did
problem.
you talk to Mr. Belgrade yesterday?
Yeah, I stopped in there for a little while. I think we got things worked out. I'm going to go check on them later today.
That sounds good.
All right.
Thanks.
Yep.
Thanks.
Yep. Okay, but let's finish up this problem here. So, okay, we made them both the same y's or the same x's. So we got those 3's matched. We need to make one of the rows negative. I'll probably make the second one negative. Make them all negatives because I need to make them opposites, right? And then we're going to add straight down. So the x and x add, they make 0. They literally eliminate each other when we're adding straight down, right? And then everything else should be a nice clean number. So if we add straight down here, the 15 and the -3 makes 12 y's. And then for the 57, and we're going to subtract 21 because we're adding those numbers straight down, we're going to get, what, 36? And as I said, these usually work out to be nice clean numbers. So what does my y have to be? 3 for that to work out. So on my coordinate, there's half of your Google form answer right there. It's 3. 3 in the second number, right? That's the y number. We found the y again. You can find x first, I don't know. Now, what do we have to do with it? Plug it back in. Okay, I'm going to probably use, I think I'm going to go with the top equation. I don't know, I think the top one looks easier. So this is the top equation. I'm going to use this one. It doesn't really matter. You can plug it in either one. I'm going to plug the y of 3 in. So I'm plugging that 3 in for the y location. And then solve that thing out. So plugging that y, this turns out to be 15 right there. 3 times 5. Because remember, just the y leaves. The 5 was still sitting there. It's 5 times y.
Subtract 15.
Subtract 15, what do we get? 4. 4 plus 15 is 19. So there's your coordinate. This is the answer you need to submit on Google. Oh my gosh, what happened there? That was terrible. All right, there you go. So there's your answer for the Google form. For those at home, you just got your answer. I'm going to leave that up. If you want to go submit that on your Google form, you are good to go for the weekend. Remember, homework's due tonight. Submit it on Google Classroom. Thanks for tuning in. Remember, next week, I think you guys that are at home are here in class in person, so permitting. And then make sure that you're submitting homework tonight, and make sure you are ready to go for Monday. For those who are in the room, I will not see you Monday. So you'll need to zoom in. I send out the links probably tonight, and I'll also send it out Monday morning, so be ready to go. If you're not in class, you better have warned me, or you better have called the office to say that you're going to be gone. So, because they have to mark you as absent. So, you have to do both. Hopefully you guys signed up for lunch.